Hi everyone, thank you for joining. I'll just wait for a couple of seconds and we can then get started. Really appreciate everyone joining in. So, hello and welcome everyone to our webinar, How SingleStore Monitors Tens of Thousands of Clusters with Petabytes of Data in Real Time. My name is Yukti and I will be your moderator today. So one of my main jobs here at SingleStore is to organize weekly AI webinars. We organize 2 or maybe 3 webinars per week demonstrating different data and AI use cases and different tools and technologies. So I also post about our upcoming webinars here and now. So if any of these topics are interesting to you, please feel free to connect with me on LinkedIn so you can stay in the loop. I'll also like to hear your feedback or any ideas or suggestions on topics that you want to session. Next slide. We have amazing sessions that are coming up. So on July 29th, we have how to build an LLM chatbot powered by agents. So we have a guest speaker from Amazon joining us, who's a part of the AI leadership. And on July 30th, we have how to build real-time AI apps on Iceberg data. If any of these topics are interesting to you, please RSVP right now, and I hope to see you all there. So you might also notice that we have an auto RSVP feature to our future AI webinars option on our website. So if you visit any of these landing pages, there's now a checkbox to auto register, which will add future upcoming Zooms automatically to your calendar, which you obviously do not need to join each webinar live. But this is just an option for those who have requested to automatically receive the video recordings and GitHub links that are relevant for the session. So coming back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button, which is present at the bottom of your console. We have an internal mission statement to try to answer 100% of the audience questions, even if that means following up with folks afterwards via email. This has gotten a little difficult over time because sometimes we have more questions that we can take up live, but it's absolutely fine. We are up to the challenge. So just make sure to ask away. Just make sure that you have logged into Zoom with your real name and your email address because we will not be taking up any anonymous questions. Uh, just strictly, you can use your Q&A button that is present at the bottom of your console because I see that participants have raised their hands, but we don't really follow that concept. So just feel free to drop your questions using that button. So as you can see on your slide, we love you all to have a dynamic experience during this webinar and try out the technology we are showing off today. In fact, anyone who tries out today's raffle will be entered for a chance to win either branded new AirPods or Meta's new Ray-Ban LLM smart glasses. It's simply the winner's choice. Simply click the link that's present on your screen or scan the QR code, which will directly take you to the landing page, and you can log in. I will be putting everything in the chat as well. So if you already have an account with us, just log in. And if you don't, rest assured that we also have a free tier that just takes about 30 seconds to sign up. And I will announce the raffle winner today before the end of the session. So moving on, I'm very excited to announce our speaker today. Joining us today is Tilak, who is a product manager at SingleStore. And we also have Akmal, who is an expert at SingleStore and will be taking up any technical questions that you all have. So Tilak, the stage is now yours. Thank you so much for joining.
Thank you, T. Welcome, everyone. Today, I'm excited to walk you guys through how we use SingleStore DB as an observability store to monitor tens of thousands of clusters, managing petabytes of data for our customers. We'll jump right in by understanding what observability means to our customers, and we'll take it from there. If SingleStore is a Ferrari, observability is its instrument panel. What I mean by that? Imagine yourself driving a Ferrari at 100 miles per hour without its dashboard or instrument panel. You'll not have any insight into how fast you're driving, engine warnings, fuel warnings, etc. And it will not be a comfortable drive. Similarly, observability gives our customers visibility into health and performance of their databases. It helps them keep their workloads highly performant and systems healthy. Let's take a look at high-level requirements for observability for our customers and how we have built the observability for our customers. The key requirement for observability to get better visibility into the database in real time. We collect 500 plus metrics, both low and high cardinality, to help our customers observe the DB. And in real time, it requires us to have a super fast speed of ingestion rate and accelerated workflow and DevOps. Customers want to have minimal time to detect and resolve an issue which involves analyzing these 500 plus events, time series of events and metrics as things happen in the system. And this requires us to have a DB with high speed of query performance. And reduced operational cost, we need to have smart observability and alerting that reacts to patterns in real time. This requires a DB that can contextualize data in real time, and all of these to be supported across our customer base that would delight them and support them efficiently with high concurrency. Now, given these requirements, which database can support all of these better than SingleStore, right? And I know we all love numbers. I want to take you guys through the scale of what we're dealing with here, just to show you how our customers use observability and what we have built. So we collect and ingest 10 million plus events across all our customers' clusters that totals a DB to have 1 trillion plus records across our tables. That involves both, again, low and high cardinality data. And we intend to support our monitoring dashboards to refresh under 1 second, so customers can make speedy understanding of events and correlate events across different metrics. And also built to support 100,000 plus users. So that's the scale that we're dealing with. And let's see how SingleStore DB is able to support such a high volume of data in real time and able to both transact, analyze, and contextualize in real time. Now, let's take a look at what is under the hood and how SingleStore is able to do all of this. We have a natively built Prometheus-style exporter that gathers data from all our customers' clusters. And then we use our data pipeline to blazing fast ingest data into our SingleStore DB. Now, a SingleStore database default data type is disk-based column store. But in front of that, we have a in-memory sort of a speed layer that can accept newly inserted events really quickly using in-memory row store segments, and then ages into a column store format asynchronously within a few minutes of persistence in the disk, and is then returned into our object store, what we call as unlimited storage. Now, our clusters or workspaces are distributed and made up of several nodes. What you see here is a workspace with one aggregator and 4 nodes. The top level node is an aggregator, and then the bottom 4 are our leaf nodes. Table or data is split up horizontally across our leaf nodes. And from this picture, you can notice that the users connect to aggregated nodes and submit queries to the aggregated nodes, which then farms out into queries into different leaf nodes to gather the data and present it to customers. We're extremely scalable. You can have a cluster with 2 nodes to up to a couple hundred nodes. And we have customers that we support with 2 CPU cores up to like 1,000 to 2,000 CPU cores. And we can scale as small or big as your workloads demand. And this is how we're able to transact, analyze, and contextualize data in real time. I'll also show you a quick demo of how our observability setup and how fast it is, and also give you an insight into what observability features we also give as part of SingleStore cloud offering natively. So before going into the demo, I want to first give you a quick overview of what observability functionality we offer in general for our customers. So imagine a SingleStore database. If a customer wants to know if the system is healthy, we give real-time alerts. It's configurable. Customers are able to configure by threshold and different time intervals to validate these alerts against. That tells you if the system is healthy or not. If the system is unhealthy, or if you want to simply observe the system performance, you will be able to observe with our dashboards that we offer out of the box, which gives you insights into different resource utilization levels and different metrics. We'll dive into those metrics in a moment. And from there, you'll be able to classify your problem into 3 areas. 1, if you feel your workloads are resource contention, then you could scale up the resources. Or if there's any other issues that you want to mitigate, you could correlate across hundreds of metrics and events and mitigate issues effectively. Or if you feel like you have some newer workloads that may benefit from optimization, you could use a workload monitoring, which gives you query level information on who ran the query, how long the query ran, some resource metrics around the queries, etc., for you to pretty effectively observe your workloads and optimize them using a query profiling tool. And if we have done a lot of advancements in the query profiling tool, that will help you to get a better query tuning experience overall. So with that, let me give a quick demo of our observability features. So today I have an out-of-the-box dashboard that I want to show you guys on different metrics that we offer for customers. Let me start by loading. So I have for 30 minutes, you can look at again alerts fired. There's no alerts fired in the last 30 minutes. Resource utilization. So notice how fast these dashboards load at just under a couple of milliseconds. So it gives you CPU utilization, CPU throttled. These are like the three key fuels that powering your system: CPU, memory, and disk. It tells you how your system or workloads are using up your resources. And this gives you more information. You can observe patterns. You can see if there's data skew by looking at how different nodes are using CPU versus other nodes. And if you notice here, the average is around 20% versus one or two nodes are at 40%. That indicates that there may be a data skew, which that one or two nodes are working more heavily than other nodes, etc. Now that you have seen the resource utilization across CPU, memory, and disk, we also have other metrics that would be more insightful. And like disk throughput, again, gives you read bytes per second, write bytes per second, or IOPS, read and write IOPS per second. And notice how when I open a dashboard, like all four panels just right away loads, and it is streaming data live as we speak, and it has 1 minute of granularity right now in these graphs. And we also give metrics about connections and threads, how many threads are connected to the system, how many threads are actually running queries, and aborted connects and total connections per second. Again, these helps our customers understand demand and concurrency. If there's any deviation in the pattern, it'll also help them observe where those deviations come from, what is causing those deviations, and debug from there. And for memory, we also give further breakdown. So let's say you're using 31% of your cluster's memory. We give further breakdown of what is consuming this memory. We are now able to observe how much of that memory is being consumed by data, how much of that memory is being consumed by queries or other system processes, etc. And down below, we further break it down by different allocs consuming memories by data, query, or other. And as you see these fluctuations, and imagine if you have a huge fluctuations in query, then from here you can flip into workload monitoring and observe which queries are the top memory intensive queries that you want to observe and fix those or take corrective actions there. Similarly, you can break down further in disk as well, how much of the disk is being consumed by data, how much of it is being consumed by trace logs, audit logs, plan cache, etc. We further break down data by different components consuming within data, like transaction logs, snapshots, blobs, etc. Also, you get by databases, etc. So if you notice, like we give wealth of information from monitoring that gives you enough visibility for our customers to understand what is happening in the system, and also dig 2 or 3 levels deeper to understand the usage patterns and how we can take corrective actions here, etc. I want to also show you folks what happens, how the refresh rate is if I have to flip it, like let's say like 30 days of data. So I'm selecting last 30 days of data here. And notice the graph's already updated to last 30 days of data. So we have a granularity of 1 minute, which is not common across, even if you go to Datadog or other observability tools. As you flip to higher period, the granularity reduces, and it probably would be 1 hour of granularity. But We still provide our customers 1 minute of granularity, so it's easy to debug short spikes, etc. And of course, if you don't want this granularity, you can also flip it to a more automated, more coarse view. Yeah, so this demonstrates how fast SingleStore can be for such a volume of data. So we are parallelly ingesting thousands of events every second, every minute, and we're also resonating that in real time in these dashboards for our customers. And in a minute, I'll also show you our query history tool, which is also amazingly blazing fast, and is the volume just increases drastically, and you can see how helpful that is in general for observability, and also you can see how SingleStore is able to do that in real time for our customers. Now let me flip to query history. So what you see here is a tool that traces every slow performing queries for our customers. We have hundreds of customers who run thousands of queries every second. We trace all those high frequency events that is useful for our customers. And then we surface it back to our customers so they can debug query results. So what this metric provides, it gives you when a query was started, an ID for a query, the full query text, how long it ran for. I'm just going to pick one query here and look at more details. So it gives you the full query text, including the values that you use in a query. So it's easy to debug. It gives you properties like how much time it took to run, what was the status, the user who ran it, workspaces, databases, etc. If the query errors, it also traces the full error code and error message that you could use to debug. Now imagine if this query you want to debug further, you don't believe that this 3.5 second is the best this query could run for, and you want to optimize this query. You could directly just paste this query into our editor, and from here, you can run our visual profile, which gives you the plan for our query, and it talks to you about the full query plan, helps you understand different operations that this query is performing, and tune from here if you feel like the query plan is not ideal. We also recently launched a feedback reoptimization tool. This tool would become very handy in query tuning by running a reoptimization. What it does is it collects the actual data from the first run, and then it reoptimizes iteratively to build a better plan that is based off of real data. And how is it impactful? Now, every time we build a query plan, we use estimates. Our optimizer is really good. It has auto stats enabled. It'll have statistics and sampling. But irrespective of statistics and sampling, an optimizer could have a poor estimate if you have high orders of joins. Let's say you have like 5 or 6 joins. Starting from third join, your estimates can become poor, and any optimizer would start to give a poor estimate. And a couple of poor estimates could actually result in a hugely bad plan. And this reoptimization tool is intended to automatically self-heal these problems. So when you first run a reoptimize, it'll run the plan first. It'll use the actual data from the first run, and then it'll reoptimize using the actual data instead of estimates. So that way we get better data to reoptimize the plan. And it runs iteratively until the plan converges. So you get a better plan eventually. And we tried this with join order benchmark. We saw significant improvements across 30% of the queries of that benchmark. And sometimes we see from 2x to up to 70x improvements in query tuning. So that's an end-to-end story about like how you would be able to observe your system health, and look at workloads, and also tune your queries from here. And hope I was able to show you guys how observability is faster. Yeah, hope you guys enjoyed the demo. I want to open up for more questions at this point and see if I can answer any questions live.
All right. Thank you so much for the demo. So we have few questions. And Thanks, Akmal, for taking up those questions. One question is, Akmal, will you like to pick one question up?
Yeah, there's a question there from AJ. It says, can you explain if there are any data pipeline limits and how they are handled? Technically, what he's saying, in other words, proprietary solution, question mark. Are there any associated costs to scale?
So our pipeline is a Kafka-based streaming mechanism. So we stream data live. There's no arbitrary limits. I mean, you can have logical limits through resource pool if you believe that you don't want to spend all the resources on the pipelines. But we do have inbuilt throttling that would stream data real time. And depending on the size of your cluster, we can write millions of events per second.
Okay. Tilak, I think there was another question. Let me just see. So Raju asked the question, can I customize the dashboard to add more metrics? So the example he's giving, something like Microsoft SQL Profiler, for example. I mean, I know we have support for Grafana as well, where you can do a fair bit of customization, but I'm guessing the question is more about what you showed, if that can be customized.
Absolutely. So we have natively built dashboards which are not customizable in nature, but then we also offer metrics API, which is built with open metrics standard that you can integrate to any third-party tool of choice that you feel like. So you could pretty easily use that API and build custom dashboards on that API, which exposes all the data that we have in our monitoring DB, and we expose in our out-of-the-box dashboards. And we also have native integrations with some observability tools like Datadog and Neuralink. If you guys are already using those tools, you could pretty easily build custom dashboards in those platforms as well.
Okay. And then there's another question here. It says the Xplan feature is cool. What optimizer is SingleStore using? Cost-based? It's a cost-based optimizer, isn't it?
We have a cost-based optimizer.
Yeah.
Yes.
Yes. Okay, great. Thank you. So just clear some of this backlog here. Yeah, AJ has another question here. This says, does the query optimizer automatically take care of multiple joins in a query? In other words, can potentially create views, change the data structures for data retrieval, data would be in memory or requiring retrieval from the clusters, for example. So there's quite a lot in that question, I think. So
yeah, so our optimizer is built pretty smartly to get a pretty good plan for multi joins, and we have extensive benchmarks done, and you can compare across industry. We are pretty fast compared to other databases. We do have projections now, which allows you to build secondary physical database design on the table if you want different shard or sort keys. We're also working on materialized views, which allows you to have more aggregates that are pre-computed in nature, which will even faster the queries. The feature that I talked about, feedback reoptimization, which currently is a manually triggered feature, but it comes handy when you have poor plans built due to misestimates, and to self-heal those plans. So as I talked about, it is essentially doing the same optimization, but as every optimization round, it gets better actual data, and it is able to give you a better plan eventually. So these are all the tools that we have available that could help you in these situations.
Yeah, great, thank you. Sachin has a question here. Does it integrate easily to my current ML applications? I'm assuming ML is machine learning. So Sachin, correct me if that's not the correct interpretation. But that's a kind of a tricky one, isn't it? It's
yeah, absolutely. We are MySQL compatible, so yes, I mean, we have to get more information on the application itself, but if the application are integrated to MySQL, then yes, we could, in theory, be able to integrate. We have a data platform building, a Nova service, which essentially you could think of building your own ML services within SingleStore and not moving data out, which is a pretty amazing feature. And we are maturing it there. So that's something that you can also explore.
Yeah, and I think, Sachin, I would ask my little piece here. So we've done lots of webinars on machine learning with SingleStore over the past couple of years since I've been here. And so SingleStore, I mean, it integrates very nicely with external libraries and tools. So Apache Spark, for example, if you're using mlib, it's awesome. And you can actually fire up Spark within our notebook environment as well. I mean, it won't scale to a huge distributed system, but if you want to work with data at a fairly small scale, it will certainly work. And I've done the demos for that. And if you're working with things like vectors as well, very straightforward. I mean, we've had vector support since 2017, as I've mentioned many times previously. And additionally, some cool announcements within the last day or so. So if you're working with, say, MongoDB, we have SingleStore Kai, and we've just added support for the dollar vector search operator in Mongo Atlas, that you can get there. That's for dealing with vectors. So lots of possibilities in terms of vector capabilities and machine learning applications in general. So
Absolutely.
let's have a look. So here's a good question. So Sagar is asking a question: how does the system handle text and structured data together?
So SingleStore handles multi-model. We can handle from relational, JSON, time series, text, and we have done quite an extensive investment in vector search and full text search. There's a lot of demos and blogs that I would read. Like, this is a pretty broad question and very hard to answer right now, but there's a lot of webinars recently that we've done. There's also a webinar that was done last week from my colleague Eric Hansen about full text search, which deep dives into all the features, all the greatness that we have worked on so far that will benefit you. So I highly recommend viewing the webinars or blogs. And if you have more questions, of course, feel free to reach out, and we're here to help.
Yeah, so Sagar, I would just add to what Tilak has said there. So things like multi-model support, again, the product has had those capabilities for some time. And as you know, most relational databases can handle text very easily, varchar, for example, but even, long text for dealing with much larger documents, for example. And if you're working with unstructured data as well, things like JSON, for example, the product has had that support for some time, and it's got even better with the SingleStore Kai for MongoDB compatibility, which, as you know, MongoDB is a document database. So SingleStore happily supports those capabilities as well. And I think, as possibly, the gist of what you're asking is maybe, how does it handle these and how does it optimize these? That's a great question. With all these different data types as well. SingleStore has a long history in terms of where it's come from. So the engineering effort has gone into the product in a big way, and it's been around for some considerable time. Started off purely as in memory, added columnar support, but all these multi-model capabilities, we have customers deploying these in production environments. So again, just reach out to us if there's things that you need to know more of or you'd like to see examples of. We'd be very happy to follow up with those with you. Okay, so it's a great question here from Jeremy. He's Jeremy Sutton. So Jeremy's asking, when looking at historical workload monitoring, what stats have the most impact on the system? Execution count, elapsed time, CPU time, memory, or other? How do you find the query that has the highest impact? That's a great question.
That's a great question. Yeah, certainly. So this depends on situation, honestly. So how does each impact the system's execution count? So as you start to see a high execution count, it could naturally start to use more resources across all the three fuel, like CPU, memory, and disk, or in one area, right? Like, depends on, some queries are more CPU intensive, some are more memory intensive or disk intensive. And depending on where the resource contention is, I would focus on those queries that are impactful for debugging aspect. So if you have more CPU being reached to 100% and being pegged to 100% for a long time, then I would start by looking at top queries that are CPU intensive and start by optimizing from there. Versus some queries are more IO intensive, disk IO intensive, but pretty fast in terms of CPU, then I would look at optimize. So it depends on which resources and where you are looking to optimize. things would differ. And different patterns can give you different things. So like say if you have a natural growth in execution count and all your resources grow accordingly, then it could be an indication that your workloads are growing and the resources are reacting to the growth. So which means you could potentially scale up. But if your execution counts are remaining to be stable, but the resources are getting pegged to 100%, then there's a serious trouble that you could start investigating into, like which resources is being contained like towards the 100% limit, and then start by debugging from there. And having historical pattern can also give you a lot of information on different changes in behavior, etc. So I would start looking at it holistically and approach where the problem is, and look at which would bring you more impact, and start by addressing it from there.
Yeah. Great. Thank you. So Mohammed's got a question here. He's asking, how do you compare your search platform with Elasticsearch? Maybe I can just add a couple of words there, Tilak, and then you can.
Absolutely.
As mentioned a little bit earlier, I mean, we are multi-model. And so we've had the Lucene full text engine support for quite some time, and that's actually received a bump just recently. There's been improvements around that. There is a blog post, which I think is a couple of years old, comparing us against Elasticsearch for geospatial data. And I'll find the link. And because we had that question previously as well. So, Mohammed, I'll share that in the chat with you momentarily. Hopefully I can find it before we finish. I mean, we're only at 6:30 at the moment, so we've still got about 30 minutes of Q&A, but I'll look into that. Tilak, you want to add something? Or maybe you've got some comments on that as well.
No, I think you covered it. Yeah, I think there's
Okay.
benchmarks and
All
blogs
right.
that we could compare.
All right, great. So Guru has a question here, Guru. Can we configure the threshold-based SNMP alarms from Grafana? That's a good question.
Not sure
So
what SNMP stands for, but yes,
Yeah.
our alerts are all threshold-based. It's configurable. We have built it natively within our portal, so customers would be able to configure different thresholds and different time intervals where the metrics are monitored and send alerts on.
Great. Okay, here's a great long question from Joy. So let me just read the whole thing, okay? All right, it says, your monitoring system looks great. Can SingleStore's monitoring solutions be integrated with databases hosted internally, such as those managed by financial clients who prefer on-prem hosting? Specifically, can your system provide a clear and tidy interface for real-time analysis and monitoring while maintaining the security and compliance standards required by financial institutions? Additionally, is it possible to utilize APIs to facilitate seamless integration with our existing systems and workflows? So this is, I think, often a concern where people, may not be very comfortable or for various legal or other reasons cannot run things in the cloud, but there has to be on-prem. And so I guess the question is, can you do the equivalent of what you're showing, but do it on-prem?
Oh yeah, absolutely. I mean, we do support on-prem and cloud deployments. We support some top Fortune 500 banks as our customers today already. And yes, our monitoring solution can be on-prem. You do get the exact same capabilities that we talked about, but hosted on-prem. You can set up the exporter, the pipelines, and databases all within your premises pretty easily. It just takes literally 10 minutes to set it all up. And we are known for real-time analysis and real-time analytics. So it gives you faster ingestion speed and ability to transact, analyze, and context all in real time. Not just in the monitoring side, but also for your own applications. A lot of our banking customers trust us for that, and they use us, and all while maintaining security and compliances. And I'm pretty sure these big banks also have done an extensive review process before using SingleStore in their applications. And yes, you could use the monitoring API to facilitate seamless integration. It's open metric standard, so you could use OpenTelemetry or any other general observability tools that would pretty much every observability tool adheres to the open metrics and OpenTelemetry standard. So you could pretty easily integrate the API into an existing system and workflow. And we've built considerably for that.
Great. Another question here from Guru Dutt. It says, other than Grafana, is there any tool you will suggest where we can integrate SingleStore DB to monitor the resources consumption? I know there was Datadog we have, which I've written a couple of short articles on in the past. So I definitely know these two as external tools. I'm not sure, but you mentioned Tilak, that it's open metrics. Was it if I got that correct?
Yeah,
So
absolutely.
presumably that's some kind of open standard that's available. And if tools adhere to that, it should be possible to use it, and with the API support.
Yeah, absolutely. Yeah, we have native integration with Datadog and New Relic as well now. So those two, yes, you can use out of the box. And then, yeah, our metrics API is open metrics standard, so it could pretty easily integrate to any observability tool of choice.
Right. I'm just clear through some of these. Let's just have a look. There's another question here from AJ. This is, does the query optimizer automatically take care of multiple joins in a query? In other words, can potentially create views, change the data structure. Oh, sorry. I think we've done that before.
We've done that, yes.
Yeah, sorry. AJ, you got to call out there twice there. I forgot to clear it. I thought your question looked familiar. Okay, so Sagar is asking, do you have any resources/use cases for real-time recommendation? That's a great question. I mean, we've done webinars on real-time kind of recommendation systems, and it's interesting that you should ask that, because just last week I was in Berlin at the We Are Developers conference, which was huge. I mean, 15,000 developers there, where SingleStore, we ran actually the same workshop on 2 days, where we were looking at the, in quotes, the Netflix problem, how to take users and be able to recommend movies to them. And similarly, if we got new movies, how would we find the users that would be best in terms of targeting and getting them as customers? Quite a challenge. That's much less of a real-time problem, much more in terms of just simply building a recommendation engine based on existing data. But we do have, I think there's an e-commerce demo that we have, which is, I think it's singlestore-estore.com, which I think, if I'm correct, you can try out. That's much more, again, in terms of there is an existing data. You want to search for certain items, for example, you put in what you're looking for in English. So you might say, I want I don't know, sort of pajamas and a top for something like this, and it's got to be this color, and it will give you a set of recommendations based upon the data that it has. And again, you have the option to narrow down, filter that down to specific sizes, for example, small, medium, large, extra large, so on, colors, and so on and so on. I mean, different styles as well. So that might be worth looking into. But we do actually work with lots of customers, and one of the benefits of our technology and one of the key sort of differentiators is, again, performance. This is something that engineering have really worked on over the years, because we work in many real-time environments, and real-time means real-time. And I appreciate it can mean different things to different people, but kind of sub-second, seconds, slightly longer, maybe. It just depends on your requirements. So it can be very, very fast indeed. Let's have a look. Let's see. Oh, okay. So Ashad's got a question here. So he's asking, what are some common challenges faced during real-time data ingestion, and how can they be mitigated? So, I mean, what I can just add here, and I'll hand this over to Tilak to answer. So, I've worked with Kafka, and I often use Kafka for my demos as well. So, these are taking feeds where you've got topics, for example, might be, say, stock ticker, for example, where data is arriving, it's a feed, and you're just getting information about stock symbols, high lows, high, low, close, open, these sort of prices, the volume of trades as well. We have this concept of pipelines, which it can ingest data at scale in parallel and very, very quickly. I mean, this is the ability to get the data in and process it very quickly as well. So those are some of the scenarios that I've worked with. And again, we have banks, from many different verticals where customers really need information very fast. So if you think about situations where you got IoT data, for example, where data maybe need to be processed. So large quantities of fairly small data arriving very, very fast, need quickly, quick processing, make some decision, for example. This could apply in other areas as well, such as medicine, for example, where let's say we've got heart monitors for patients, okay, where it may be quite critical to make decisions very quickly. So there are lots of situations where this occurs. And again, we have, the architecture of the SIM. It's the distributed, shared nothing architecture. Can consume data at scale in parallel using this kind of pipelines concept. So there's a very great way to get data in fast and be able to process and query that quickly as well. It's okay. Another question there from Germany said, could you show what the workload profiler does in the portal? Does it give any other information that would not be available in historical workload monitor, which we currently use? So I'm guessing there, Jeremy, you are an actual user of the technology as well.
Yeah, certainly. So yes, the workload profiler and historical workload monitoring sort of has a similar information. Now, when will workload profiler become handy? So let's say you are having some sort of a system breakdown, you're having a lot of queries running at this time that you want to debug something that is happening in the last 10 seconds or 5 seconds. Then you could have a workload profiler profile it for 5 seconds. It'll just summarize everything that is happening in that 5-second window. And it takes a snapshot of that 5-second window and shows you all the queries running in the last 5 seconds, all the different metrics like CPU, memory, disk, of those queries are running in the 5 seconds, and just the resources utilized in that 5-second window. Versus historical workload monitoring essentially has the same data that goes back to the last 30 days and gives you a historical pattern of all that information. So yeah, so workload profiler comes handy if you are trying to look at the system at the moment, like let's say like 5 seconds or 10 seconds of the system that's live. Versus historical workload monitoring eventually has all the data in under a minute and goes back to last 30 days. So you could get more enriched information by looking at the time series information.
Right. Just yeah, and Saga's got a follow-up question. So I'm just in the process of answering that. But more generally, in terms of chat capability, for example, we have something called Squirrel, which is a technology that we've built, which essentially is drawn upon our blog posts, our forums, our documentation. And so you can chat with that system, ask it about SingleStore, anything and everything SingleStore, and it will give you answers back in real time. So you can actually ask it to write SQL queries for you or explain some concept to you. So that's a very useful way to work with our environment as well. Oh, Ravi's got a great question here, Tilak. So it says, how to have MQTT connector and or Spark Plug B client with your system instead of Kafka. I confess I've not heard of Spark Plug B. MQTT I've heard of, and Kafka I know about. That's a great question. I'm not sure. On our GitHub repo, we actually have two main ones. One is MemSQL, the other one is SingleStore Labs. I think one of them, the connectors are located there, and you can find details of all the connectors that we have. If you have a specific requirement, just drop us a line and let us know. I mean, if we get enough interest from a particular customer, for example, it's something we might build. But the MQTT, I'd need to look into. I don't think off the top of my head we have one, but I could be wrong. The Kafka, definitely. I mean, that's easy. we do support that. Okay, so Joy has a question here. Do you work with MSPs to offer this as a SaaS?
I guess they're more like a CSPs, like cloud service providers. I'm not sure what the MSP stands for, but if it's cloud service providers, yes, we work with all major cloud service providers like AWS, Google, and Azure to offer this as SaaS.
Yeah. Okay. Great. Okay, so I see the Q&A is empty now, so we've kind of got there. Hopefully, oh, there we go. So Mario is asking a question. How can I obtain more credits? Great question. So I'm guessing this is about the actual credits when you sign up. So I think the way to do it is typically within the portal itself, there is a way to contact support, kind of help, if you like. And if you reach out to support via that mechanism to request that, hopefully they'll look upon it favorably. What I would say is that I've been with the company 3 years now. I mean, this month is my 3rd year anniversary. Just before I joined the company, I created an account. And in those days, I think it was only worth $500 worth of credits. And I manage those credits very carefully. Even today, I've got several $100 worth of credits still outstanding. But I've switched to using the free tier, which works great for most of my kind of applications and demos. But I appreciate that, there are some limitations on that. You're only allowed like one database, for example, certain number of tables, certain quantity of uncompressed and compressed sort of data, and so on. But I think, Mario, the thing to do would be to reach out to support through the portal, okay? Use the help facility there, and then just raise that as a question to them and see if they will be generous enough to give you more credits for that.
Okay.
Okay, Yukti, I'll hand back to you. So I'll just go quiet now. So
Thank you so much. That was such a nice, productive Q&A session. I see one more question from Sagar. They say, are there any healthcare specific use cases that you can discuss? I think we have a webinar on this with Vinija Jain, right? So Sagar, you can go to our resources page and you can, it happened early in June, so you can go and check that out. I think I'll be able to provide you with the link as well during the session. But if you can share your slides again, I can wrap it up by announcing the raffle winner and the upcoming webinars. Thank you. So, all right. Thank you so much, everyone, for such a productive Q&A session. And if you have any questions, feel free to reach out to our team at team@singlestore.com, because obviously all questions can't be taken up in great detail. So just quick notes before I announce today's raffle winners. So we've got amazing sessions that are coming up over the next few days. So RSVP to our upcoming webinars. On July 29th, we have how to build an LLM chatbot powered by agents. On July 30th, we are presenting how to build real-time AI apps on Iceberg data. So if any of these topics are interesting to you, please RSVP right now. I hope to see you all there. So the announcement that you all have been waiting for, today's raffle winner goes to Greg Taylor. He's a lead cloud architect at Sony. Congrats and thanks for joining, sir. And if that is not you, please do not give up. We're going to announce one more AirPods and Meta's Ray-Bans winner by the end of the day for anyone who has tried out today's demo and signed up. You can still sign up by scanning the QR code present on your screen, or you can access it in the chat and be eligible and be entered to win. We will announce one more winner by the end of the day. Thank you so much, Tilak. Thank you so much, Akmal, for taking up the questions and the demo. We really value your time and energy. And most importantly, thanks to our attendees for joining from wherever you are and giving some time of your day. So I hope to see you all in the next sessions. Thank you so much, everyone. Bye-bye.
Thank you, everyone.